Good morning, Geometry Honor students. So Mr. Chen again. So today I would like to talk about some of the problem that you might be dealing with for the geometry final. So for the geometry students, so this one would be like one of the benefits for you. Okay, so instead of going through everything else, so this one you can try to solve for some of the problem that I'm explaining for this lesson today. And now let's take a look at that. So if you guys do recognize the segment addition postulates, so we do have AB, so that's x plus 16. So BC, 5x plus 10. And then AC, the measure of this segment, is 56. So let's say that you want to find out the measure of segments BC. Okay, so find BC. So the way to do it, so this one segment addition postulate, so AB, BC, they're given already. And then AC, all those points, they're considered collinear. So that means x plus 16 plus 5x plus 10 using the segment addition postulate, so that equals 56. Combine those like terms, so we do have 6x plus 26, so that equals 56. And then solve for x, so we do have 6x equals 30. And then divided by 6 both sides, so we do have x equals 5. So plugging a number back to the expression for BC, so we got 5 times 5 plus 10. So 5 times 5, 25 plus 10, so then that'd be 35. So the proof, 2-column proof. So normally your teacher expects you to either fill in the statements or the reason, so fill in the blank for the proof. Always started with the given, so AB equals DE. Okay, so AB equals DE. So put a little tick mark right there so they're equal. So AD equals BE. So AD equals BE. Okay, so AD right here, so that equals BE. So started off with the first reason, so that obviously is given. And then AB plus BD, so that equals DE plus BD. So this one, I would say that it's segment addition postulates. Instead of using segment addition postulates, so let's say that this one is addition, property of equality. And then AB plus BD equals AD, so this one would be the segment addition postulate. And then finally, AD equals BE. So the last statement, so you want to say that this one is the segment congruency. Okay, so now let's see what else that we have. So the diagram that we have, so we got angle 1, 2, 3, 4. So there's a lot of angles given here. So given that measure of angle 1 equals measure of angle 3. So given. So measure of angle 1 plus measure of angle 2. Combine it together, it's the same as measure of angle 3 plus measure of angle 2. So this one is also considered addition property. And then angle 1 plus angle 2 equals measure of angle AFC. So this one's called the angle addition postulate. And then finally, the measure of angle AFC equals measure of angle DFB. So this one would be considered angle congruency. Okay, so here's another one. So given line M, So given that line M and N are parallel, so I keep doing that, the cross line there. I want to use the arrow to make this bigger. So transversal T intersect line M and N. Okay, so you want to prove that angle 1 it's equal to measure of angle 7. So start off with the given already. So measure of angle 1, it's the same as the measure of angle 3. So this one, I would say that 5 and 7, so definition of vertical angles. Measure of angle 3 equals measure of angle 5. So this one would be considered alternate interior angles. And then measure of angle 1 equals the measure of angle 5, corresponding angle. Instead of using corresponding angle, let's say that's the transitive properties of equality. And therefore, measure of angle 1 is the same as the measure of angle 7. And also this one by using transitive properties of equality. Okay, so now let's see what else that we have. So complete the reasons for the proof. So given that AE is parallel to DC, AB is congruent to DB, obviously that's given. Measure of angle A, so it's congruent to measure of angle D, so this one would be considered alternate interior angle. Okay, so I'll just abbreviate that, alternate interior angles. So measure of angle ABE is congruent to measure of angle DBC, so vertical angles. And then triangles ABE is congruent to triangle DBC. So this one is by using angle side angle. Okay, angle side angle, angle side angle. Okay, so another one, the ratios of the side lengths of a triangle ABCs are 7 to 9 to 12. So this one's the ratios of AB versus AC versus BC. Solve for x. So first thing that you want to find out is that the total ratio, so 7 plus 9 plus 12. So then that would be considered 28. So 7 plus 9, that's 16. 16 plus 12, 28. So in order to find out 6x, so 6x, so the ratios of AC, which is 9. So it's going to be 9 over 28. So that equals 6x all over. So the total perimeter, the perimeter of the triangle, so that would be 6x plus 7x plus 6 plus 28. So combine this together, so 9 over 28, it's non-reducible, so I'll put it up here. So 6x, just leave it as the way it is. So 6x plus 7x, 13x. 6 plus 28, 34. And then from here, the things that you want to cross multiply, because that's a proportionality. So check out things that we can reduce, nothing we can reduce, so simply cross multiply. So we got 9 times 13x plus 34, so that equals 6x times 28. And then the rest of that, just solve for x. So 13x times 9, 117x. 9 times 34, so 4 times 9, 36, 3 times 9, 27, plus 3, 306. 6 times 28, so 8 times 6, 48. 2 times 6, 12, plus 4, 168. Okay, so it looks like we're going to end up with it's x. So, and then what you need to do next, so you want to subtract 117x, both sides. So subtract 117x both sides, so we do end up with 51x, and then divided by 51. So x equals 6. So once you solve for x, just solve for x, that's it. So there's no need to plug in a number to find out the rest of the side length. Okay, so now let's see what else that we have. Proportionality. So given that segment PQ is parallel to segment BC, so if this one is a similar triangle, not the right triangle, similar triangle. So one thing that we notice, the shorter leg of the left-hand side of the triangle over the longer leg of the left-hand side of the triangle, it's the same ratios as the shorter leg of the right hand side of the triangle over the longer leg of the right hand side of the triangle. So basically this one reduced, so we got 1/2 9 over x. And then cross multiply, so 2 times 9, which is 18, 1 times x. So that means segment QC, so that equals 18. But you want to find out segment AC. So AC, so that means the sum of those two, the minor segment and the major segment, so AC, so that equals 9 plus 18, which is 27. So if the size length of a triangle is 7, 6, and 9, the triangles, so using that the converse of Pythagorean theorem, so a squared plus b squared, we want to find out what that equals to, with that c squared equal to or less than or greater than. So a obviously is what, 6, the shortest leg. B, the longer leg, 7, the longest leg, which is 9. So plug in the numbers, so 6 squared plus 7 squared, so 9 squared. So we want to find out what that is, whether that's less than, greater than, or equal to. So 6 squared, 36. 7 squared, 49. 8 squared, 81. Combine 36 and 49 together, so we do have 85. Well, 85 obviously is greater than 81. So if a squared plus b squared is greater than c squared, so that means the triangle got to be considered an acute triangle. If a squared plus b squared is less than c squared, then that'd be obtuse. If they're equal to each other, so that means it's a right triangle. Okay, so a squared plus b squared, the sum of a squared plus b squared is greater than c squared, so that means it's an acute triangle. So the circle, so use the diagram. So this one obviously is not drawn to scale, so we want to find out what's happening with the measure of the missing arc or the angle. Okay, so this one is another multiple choice problem. So given that the measure of the arc BCD, so BCD, then that would be this one right here, and so that's 116 degrees. Measure of DEF, DEF is 90 degrees. And then FGH, 138, so FGH, 138 degree. So and HAB, so this one is 16 degree. So once you add them all together, it's totally is what, 360. So find the measure of angle FPD. So here we go, FPD, so the external angle. So the way to find out the measure of the external angle, so there's always a formula for that. It's considered 1/2 times the quantity of the major arc minus the minor arc. So what I'm talking about, the major arc here is the corresponding arc intersected by those two secant. So 90 degree, so that would be the major arc. And then this one 16 degree, then that would be the minor arc. Because this angle is facing toward this direction. So it's always being bounded with the arc, the major, the minor. So it's 1/2 times the quantity, 90 minus 16. So 90 minus 16, which is 74. So 1/2 of 74 divided by 2, so we do have 37. So 37 degrees. So the answer is D. And then the other one is quite similar, but this one is called the chord product. So in order to find out this inner angle, so the formula for that, instead of subtracting the major arc, minor arc, so this time we want to combine them. So the way to find out the inner angle, it's always 1/2 times the measure of the major arc plus the measure of the minor arc. So it's 1/2. And this one, measure of RAB, which is 20 degree. Measure of CD, so this one is 62 degree. Again, the figure is not drawn to scale. So 20 plus 62, combine them, so we do have 82. 1/2 of 82, which is what, 41 degree. Okay, so now let's see what else we have. And here's another one. So this one is called the secant and tangent product. So secant and tangent product. So secant, that means this line segment here. Tangent, that would be this one, barely touching the point on a circle. So the way to do that, it's always tangent square So that equals the external segment times the secant segment. So tangent square, so 18 squared, so that equals external segment, which is what? X. Times secant, so the quantity of that, it's x plus 48. So the measure of the entire segment here. So what we found here, 18 squared, which is 324. Okay, so 324. Okay, and then the rest of that, just solve for x. Expand it, x squared plus 48x. So that means x squared plus 48x minus 324, so that equals 0. And then the rest of that, you want to factor it, so to find out what's happening there. So break it apart, this number looks like it's divisible by 4, so it's 4 times, okay, so 4 times 81, or perhaps using something else, factor it, and then find out exactly what the result is. Or perhaps using 36 times 9. Okay, so 36 times 9. So just find out that, whether it's factorable or not. If this one is non-factorable, so basically you just want to use the quadratic formula. Okay, so finish that one. And now the other one, sketch the graph for the circle. So to make the graph for the circle here, so what we need to do, so we need to identify the center. So the center of the circle here, which is considered h comma k. So it's 4 comma negative 3. So the equation of a circle is always written as x minus h quantity squared plus y minus k quantity squared equals r squared. So the center is 4 comma negative 3, radius, then that'll be 5. So x-axis, y-axis. So plug in the number, so plot the point. So we got 4 comma negative 3. So 1, 2, 3, 4, down negative 3. So radius is 5, so 5 units up, and then 5 units down, 5 units to the left, 5 units to the right. So count it. So 1, 2, 3, 4, 5, 5 units up, 5 units down, so I'm kind of running out of space here. So 5 units to the left, so 1, 2, 3, 4, 5. 5 units to the right, extend it. So 1, 2, 3, 4, 5, all the way over here. So eventually you're going to end up with a circle. Yeah, again, mine is just kind of out of space. So just connect that, the other point down the bottom. Okay, so now, and here's another slide. So find the volume of a cylinder. The way to find the volume of a cylinder, so it's always V equals pi r squared times the height. So diameter is given already. It's 8.5 feet. So half of it, so radius divided by 2, so then that'd be 4.25. So pi times 4.25 quantity squared times the height, 10.5. And then the rest of this, just put into the calculator and then round it to 1 decimal place. Volume of a right prism. So the way to do it, again, it's the area of the base times the height. So in order to get the area of the base, so we do know the base is a right triangle. So the way to find out the area of a triangle, so it's 1/2 times base times the height. So 1/2 times 4 times 6. And then the height of the prism, which is 5. So 1/2 times 4, 2, 2 times 6, which is 12. 12 times 5, which is 60. Okay, so the volume. And sometimes that giving with the unit, so this one is a cubic feet. And the previous one, the unit for that, is also considered cubic feet. Because volume, it's always 3-dimensional. The length, the width, and the height. Or the area of the base, that's already considered 2-dimensional, times the height. So that's why it's 3-dimensional. And then the last page, another sample problem. So a regular hexagon has an apothem of 2 and a side length of 4 root 3 over 3, then that one is going to be easy. The way to find out the area of any kind of regular polygon, so it's always 1/2 times apothem times its perimeter. So 1/2 times apothem, 2. And then perimeter, so we do know that this one's a hexagon, so 6 sides, equilateral polygon, so it's 4 root 3 over 3 times 6. So 1/2 times 2, so that's 1. So what's left here, just 4 over 3 root 3 times 6. Cross cancel, so we got 8 root 3. And then this one, there's no unit, so just leave it with that, the irrational number. Okay, so thank you for watching the video today. So in case that you do have any questions, so please just put it up there in the comment bar, okay? So I'll try to reply that as soon as possible. So I'll see you guys next time. Take care.